Hi, I'm Suresh. This is my book. I published this book on 12th December. I like to share a few things from my book. I like to compare the standard model of elementary particles with my mathematical structure of the elementary magics. I made a mathematical structure to describe the elementary particles. It is a theory I made to describe it. This is it, and I have two sides. One side is here, and other side is there. And this side you say matter side, and the other side is antimatter side, and there are more down there. And I hope this is similar to the structure of the atoms, and there are similarities to the elementary particles, something like this. So maybe these two things inside this inside this structure. The At the bottom of this structure we can find two things, there are neutrons and protons, and there can be electrons in the below. Can be electrons too, and there are currently it is under construction. Not perfectly analyzed it yet. I have to analyze it, but currently I guess this is something like up quarks and down quarks side, and there will be electrons in somewhere else. And this is the if this is the up quarks and the down quarks side, it is possible to make two particles, subatomic like particles like protons and neutrons, two things. And then electron from this side, and this side, two electrons can exist in the first level, and maybe there are and there can be more electrons in other levels. And this is structure, and I compared it with the standard model, and I think the mass, there is a similarity. It is with the spin and the charge, but also I tried to guess similarities between the mass too. So I guess a few ratios of mass, and I guess it can describe the mass too. I give something like there are around 6 elementary magics. I call it elementary magics. Few elementary structures, ghost like structures, and this there are 6 for each level. So I guess if we take the down quark as the first level, from something from the first level, then it and from that I can make 20 times. There is a ratio here. the strange quark is 20 times larger than the down quark. The bottom quarks is 40 times larger than the strange quark. So I think the 20 comes from a ratio like this. Now I explain about it. I'm going to explain about it now. If we guess the down quarks, if we take if the down quark is at here, and then the strange quark is at here, then we can count the numbers of these the elementary ghosts. The number of elementary ghosts within this section, and there are from 6 from here, 6 from the other side, and there are another 6 from here and another 6 from here. So there are around 24 elementary magics here. So 24, so I multiply this from 24, but sometimes some things can change. So 24, from 24 it can something like annihilate, and it can become 20, something like 20, and something maybe some particles can change and become irrelevant to the mass. So I guess that is how the 20 comes from 24. I reduce 4 from 24, then it becomes 20. Then the mass of at here becomes 20, and then I guess the mass of so that this can be something from here can be larger than 20 times larger than this, because it is with all the other things. Therefore it can be 20 times larger than this one, because maybe this one stay alone, and but this one is staying with all the other particles, elementary magics. So the next one, I think the next step is how this can become the next one, 40 times. How the other one can become 40 times larger than the strange one. Bottom quark, how the bottom quark can become 40 times larger than the strange quark. So I reduced 4 from 24. The next time that theory can apply to the next one also. So this time there are 24 plus 6, 30 plus 6, 36 plus 6, 42. So there are 42 here. So then I reduce only 2 from here. First time I reduced 4, now I reduce only 2. Then there are 40, number 40. So that the mass of something from this section, it's something maybe like a strange quark, can be something like a bottom quark, can be 40 times larger than the strange quark. And then this section is now fine. Now there is another section here, top quarks, and then I think Higgs field is a Higgs boson, and is a group of particles. This can be the Higgs section, and this can be this is a very only one line, and this is the main section of the the first start of this table. And it is because it is 1.1 section, so this can be the Higgs section. So the next thing I do is applying 40 adding another 6 from this section, so with the Higgs, and then it becomes 48. So then now I'm going to multiply 48 from 12, so then it becomes something around something like around the mass of this one. So if I don't change the mass of this, because it is the start of this section, and the next ratio, the ratio of this upsection charm top quarks can come from a different formation. So I guess that formation from the end of the end of this, from the end of this, it goes to here, but it can change 12 times. Can become 12 times larger than the first section, because it is jumping again back to here. So this is 12 times, so the 48 multiply 12, and it can be around this mass for 1.275, and then I multiply the top quark, and now this time I reduce 4 from the first place. 4, it means 12 multiplied 48, but I reduce 4 from that number. Then I guess it is equal to something around this. It can be the mass of the charm quark, and then I apply then I go to this section, and this time I multiply it from the numbers of this, because there are 18 here, 18 other sets here. There were 2 here, but there are 18 here. So then I multiply it from 8, 12 and 8. Then it can become something like 18 multiplied 12, 144, and I reduce 8 from there this time, and then it can it is near 140. And 140 multiply the previous one and by the previous one, and then it is equal to the mass of this particle. And so why I did so I have to give a reason to multiply this from 12 and this from 8, this section, because this can I can multiply 12 because there are two six sections here, and 2 multiply 12, 2 multiply 6, around 12, and 12 in, next thing is multiplying it from 8, this from 8, it is not perfect. I cannot give a good reason for it right now, but it is something like because it comes from that number. The number is now this can be 12 from 2 multiply 6, and this number can come from 18 multiply 8 can come from 8 or 7, 18 multiply 8 or 7, because 7 is also not bad. 1 2 3 4 5 6 7, but if I guess but 8 is better, because if I multiply 8 from 8 and then I can multiply it from 8 because there are 8 lines from here, because now I have good reason for that too, because I can see now there is 1 2 3 4 5 6 7 8, so that is maybe the reason to be the 8 to be the ratio, the multiplication number, the reason for the multiplication to multiply this the next particle, to multiply this to get the mass of the next particle, because the 8 there are 8 here, and 18 multiply 8, and then I can get the mass of this one. So maybe there are more ratios which can cause to form other particles, and you can see how this becomes very this can become the main particles of the universe, and I guess it is very similar to the standard model. I explained how it comes, how these particles forms. I call these elementary magics. So I hope you, if you want to learn more about it, you can read my book, and I hope to compare more things of these types of particles. These things from the standard model of elementary particles. So I hope this video will help us to find the nature of the reality and the theory of everything. So I will see you in the next video.